So the email extractor. So I want you to use advanced string methods and functions that we learned in 8 to extract all of the email addresses from a group of text. I want them to print out in a loop. I want you to remove duplicates from the list. And I also will provide a list of sample email addresses that you can scan for in the text. So A8 looks like this. This is the template. Okay, so I have 2 pieces of text. They're different, but they both contain multiple email addresses. I want you to create functions that will work to find the email addresses in both. I also have a list of email addresses, and I want you to tell me, are any of the email addresses that you find in the strings equal to any of these? So those are the challenge. And I've prompted you to create functions with a certain perspective. Now, like, okay, well, how do we find email addresses in text? If I'm asking you that question, how do you find email addresses in text? If I give you a piece of written text right now, and we're not talking Python, if I just put a piece of paper in front of you with some text on it, and I say, tell me what email addresses you see here, how will you find the email addresses on the piece of paper in front of you? What will you look for first? The @ sign, right? Because every email address has that. Now, is that enough to guarantee that something is an email address? No, because I might have like an Instagram handle, right? And there are some other reasons that we might use an @ sign. So, and what else does an email address have? .com. It has a dot something, right? So it's if I have an email address that looks like this, bill@bmosley.com, it has an @ symbol. It has dot something at the end of it. Okay. So it has something before and it has something after. Can it be anything before and after? No. It has certain rules. It cannot start with punctuation. It cannot have certain kinds of punctuation. It can have an underscore, a hyphen, or a period. An email address also has to have at least one period after the @ sign. It can have multiple periods before, multiple periods after, but it cannot end or begin in a period. It cannot have a period immediately after the @ sign or immediately before the @ sign. So there are some rules that if we know about email addresses, and I didn't expect you all to know all the things about email addresses because you haven't done this yet, but there are rules that determine whether something is a valid email address or not. Now, if I have an email address like this one, georgesmith@google.com, and it's at the end of a sentence, I might have a period at the end of it. This period will be included if I split that into words using the split method. That will go with the email address, but that's not actually part of the email address. So our whatever algorithm we come up with to find the email addresses has to be able to remove punctuation that's not part of the email address itself. So that has to be part of your thinking. So in this text, we have a variety of things going on, and I'll just scan through it here. So we have email addresses that look like this, but we also have email addresses that look like this. And if I split this on spaces, on white space, that whole thing is going to come back as one word. So I got some cleaning up to do with some of these. And the same function that finds this and cleans it up has to be able to clean up this one. And there's at least one here. Okay, so we got one in parentheses here. there's at least one email address that is at the end of a sentence. Here it is, that you have to clean off that period. So we've got a lot of stuff going on here. And that is the trick here of this assignment, is figuring out how do you find those email addresses. Well, I'll give you a hint. The first thing I do is split these into words. And yeah, I return everything with an @ sign. And that gives me at least a list of things that are probably email addresses. Okay, now I just have to figure out, is that actually a valid email address, and how can I clean it up? So each one of those could be its own function. Okay, or you could have one function that does it all, but that's a pretty complex function, and I'm not sure you want to go that way. Okay, so that is assignment 8. Like I said, we're going to get into algorithmic thinking as a way of approaching a complex problem like this, and it should help you sort of wrap your mind around the assignment. That said, if you feel like you want to take a stab at it, go for it. I think the best way to learn is to challenge yourself with tough things. But if the sandbox assignment is feeling like that maybe that's where I'm at right now, then play around with that and get comfortable with splitting words, splitting strings into words, and iterating through them and looking at things.